Hello and welcome to a video presentation on scientific notation. Here's what you'll learn: how to express numbers in scientific notation. Now please note, scientific notation utilizes powers of 10. If you are not familiar with the general concept of powers of 10, you may want to watch my videos titled Powers of 10 Positive Exponents and Powers of 10 Negative Exponents first. What is scientific notation? Well, scientific notation is a shorthand way of writing really large or really small numbers. The number shown below, in fact, is written in scientific notation. Numbers in scientific notation are written as the product of two factors. The first factor is a whole number from 1 to 9, or it can be a decimal number, as shown in the example below. If it is a decimal number, the whole number portion has to be a number from 1 to 9. And the second factor is always a power of 10. In standard form, which is the way we normally express numbers, the number below is 346 million. And here's how we arrive at that. Write the following scientific notation number in standard form. It's 3.46 times 10 to the 8th. We start by writing down the 3.46 from above and locate the decimal in the number. It's not hard to find. We can see it directly between the 3 and the 4. Now the exponent 8 in the power of 10 above tells us how many times to move the decimal point to the right. So we move the decimal point 8 places to the right. 1, 2, 3, 4, 5, 6, 7, 8. And finish the problem by filling in the empty spaces with zeros. So in fact, 3.46 times 10 to the 8th is 346 million. Now let's write the following scientific notation number in standard form. 2 times 10 to the negative 10th. We start by writing down the 2 from above and locate the decimal in the number. Now remember, every number has a decimal. If you don't see one, place one at the end of the number. That's where it belongs. Now the exponent negative 10 in the power of 10 above tells us how many times to move the decimal point to the left. So we move the decimal point 10 places left. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And finish the problem by filling in the empty spaces with zeros, and don't forget to place 1 in front of the decimal as well. If we don't have any numbers to the left of the decimal, we should always put in a 0 for clarification. And the answer is 0.000000002. Now let's write the following standard form number in scientific notation. We have 710,100,000. When we start writing numbers in scientific notation, we can ignore all trailing zeros. So let's start by marking those off. Next, we know that numbers written in scientific notation have only one digit to the left of the decimal point, and that digit must be from 1 to 9. So in the number above, we want to place our decimal between the 7 and the 1. Now let's start creating the scientific notation of this number by writing the remaining numbers and adding the decimal between the 7 and the 1. So we're going to write 7.101. That's the first factor. Now we need to write the power of 10 that we multiply by. Multiplying by 10 to the what power? We don't have an exponent for our power of 10. But here's how to determine the number for the exponent. Locate the decimal in the original number above. Now remember, we don't see one, but every number has a decimal. If you don't see one, it goes where? That's right, at the end of the number. Place it there. Now just count the number of times you move the decimal to the left to get it between the 7 and the 1. 1, 2, 3, 4, 5, 6, 7, 8. 8 times. So our exponent is a positive 8. The answer to the problem then is 7.101 times 10 to the 8th. Write the following standard form number in scientific notation, 82,433.12. Let's start creating the scientific notation of this number by putting our decimal between the 8 and the 2. We know it has to go there. And then we can write the rest of the numbers down. The 4, 3, 3, 1, 2 go after that. That's now our first factor. Now we need to write the power of 10 that we multiply by. And we find that by counting the number of places we moved the original decimal to get it between the 8 and the 2. 1, 2, 3, 4 places. That means the exponent in our power of 10 is going to be a 4. So the answer is 8.243312 times 10 to the 4th. Now let's write the following standard form number in scientific notation. It's a really small number, 0.00000000633. The first thing we can do is ignore all leading zeros. Now we have to put the decimal in a place where we have only one number to the left that's going to be a number between 1 and 9. So we put our decimal between the 6 and the 3. We can start creating our scientific notation of this number now by putting our decimal between the 6 and the 3. So we write 6.3, and then we add the remaining 3. That's our first factor. Now we need to write the power of 10 that we multiply by. And we find that by counting the number of places we moved to get the original decimal between the 6 and the 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. We counted 9 places. However, we moved to the right this time, so our exponent is going to be a negative 9. So the answer is 6.33 times 10 to the negative 9. Now here's some food for thought. Is the following number in scientific notation? Take a look at this. I'll give you a second to answer the question. 0.05 times 10 to the 15th. Is that in scientific notation? No, it is not. The decimal should be after the 5. It should be written as 5 times 10 to the 13th if we were going to write it in scientific notation. Since we had to move the decimal 2 places to the right, we'd subtract 2 from the exponent to compensate for that movement. Both of those numbers are the exact same number, though. One is in scientific notation, one is not. How about this number? Is it in scientific notation? 12.2 times 10 to the negative 10th. No, it is not. The decimal should be between the 1 and the 2. It should be written as 1.22 times 10 to the negative 9th. Since we had to move the decimal 1 place to the left, we would add 1 to the exponent to compensate for that movement. How about this one? 5.56 times 3 to the negative 10. Is that in scientific notation? Your answer should have said no. A number written in scientific notation must have a power of 10 as the second factor, not a power of 3. And how about this one? Is the following number in scientific notation 3 times 10 to the 23rd? The answer is yes. The decimal point is at the end of the number 3. That means there's only one digit to the left of the decimal, as is required for a number to be in scientific notation. It is not a requirement that a number written in scientific notation have numbers after the decimal point. In summary then, a number written in scientific notation must have a power of 10 as its second factor, and it must always have a single non-zero digit to the left of the decimal in the first factor. When moving the decimal in a standard form number to the left to put the number in scientific notation, the exponent on the power of 10 will be positive. When moving the decimal in a standard form number to the right to put a number in scientific notation, the exponent on the power of 10 will be negative. And don't forget, leading and trailing zeros in original standard form numbers are always ignored when writing the first part of a number in scientific notation. So congratulations! You've learned how to express numbers in scientific notation.